Today, you will take some notes on the topic of solving rational equations. Here are the 5 steps for solving rational equations. If you need to pause this so that you can copy down these steps, now would be a great time to do so. I'm going to go ahead and move on to example 1. In example 1, there is nothing for us to factor, and we don't have any variables in the denominator, so we do not need to state any excluded values. That means we can jump straight to determining what our least common denominator is. In this particular case, our least common denominator is going to be 30, so I'm going to take our original equation and multiply all of the numerators by 30. The purpose of doing this is for us to get rid of our fractions so that we do not have a denominator in any of our problems anymore. This will reduce nicely to 20x plus 6 times x minus 2, and that will be equivalent to 5. After I distribute the 6 through to the binomial, I'm able to combine like terms and solve for the variable. 26x will be equivalent to 17, and then my solution is 17 over 26. Example 2, we do have to do a tiny bit of factoring in this first example. We need to factor out the GCF of 3 here. So I'll pull out a 3 and I'm left with x minus 2. After this is factored, what I need to do is state my excluded values. These are the values that make your function undefined. And if x is 2, my function would be undefined. So there's my excluded value. Then I have to state my least common denominator. In this particular case, my least common denominator is 6 times x minus 2. Then I'm going to multiply all the numerators by 6 times x minus 2. Doing so, I'm going to get rid of all my denominators. I'll be able to simplify things nicely. So these x minus 2's will cancel out. 6 and 3, that'll reduce to a 2 up top. The 6's will reduce. Same for the x minus 2's. Now this is a little bit messy, but what we're left with is 2 times x plus 1 is equivalent to 5 times x minus 2 plus 3 times 6, which is 18. We'll need to distribute the 2 and the 5 through to those two binomials. And after we do so, we'll be able to combine like terms and solve. 2x plus 2 will be equivalent now to 5x plus 8. Subtract 2x over to the right side, and then let's subtract 8 over to the left side. Divide both sides by 3. X is equal to negative 2. Double check and make sure that negative 2 is not an excluded value. It's not, so our solution is x minus 2, or x equals negative 2. Moving on to example 3, now we've got a little bit more work to do before we begin simplifying. We have to factor our denominator on the left side. That will factor nicely into x minus 3 and x plus 1. Now I have two values that are excluded values. If my function is equivalent to 3 or negative 1, that means my function's undefined. So those are our excluded values. The next step would be to state your least common denominator, and then you're going to multiply all the numerators by the least common denominator. I'll go ahead and do so now. By this time, many of you can probably do this mentally, and that's perfectly fine. You don't have to show this work. I would just like to continue to, so you know where these answers are coming from. Then let's simplify x minus 3 and x plus 1 will cancel out. And I've got my x minus 3 factors and then my x plus 1's. What I'm left with on the left side is just a constant of 4. Then I've got x multiplied by x plus 1 minus 1 multiplied by x minus 3. Now we'll distribute through and be extra careful, especially because of this minus sign. When I distribute through, I get x squared plus x, and I'm going to distribute the negative 1 through, so minus x plus 3. Then we'll combine like terms. X squared plus 3 is what is resulting on the right side. If I subtract 3 over, I just get 1, and then I will square root both sides. And remember, when you draw a square root, you need to remember plus or minus out front. But if I go back and check my excluded values, negative 1 is an excluded value. So my only solution that works in this particular case, the only one I'm able to box in, will be positive 1. All right, moving on to our last example, example 4. Step 1 will be to factor first. The denominator that we have in the middle there is a difference of squares, so this will factor nicely into x minus 3 and x plus 3. Looking across at all my denominators, I have 2 excluded values. If x equals positive or negative 3, that would make my function undefined. So there's my 2 excluded values. Then we'll state our least common denominator, x minus 3 and x plus 3, and we're going to multiply all the numerators by those 2 factors. X minus 3 and x plus 3 I will attach to each of these constants up top. Okay, let's go ahead and start to simplify. The x minus 3's cancel out, the x minus 3's and the x plus 3's. Last but not least, the x plus 3's. What we're left with over on the left side of the equation is just x plus 3, that one binomial, plus just 2. And we'll say that that is equal to 5 multiplied by x minus 3. Okay, combining like terms over on the left side, I get x plus 5. Distributing the 5 through, 5x minus 15. If I go ahead and subtract x over, I'll get 4x. And if I add 15 to the other side, I get 20. 4 divided by 20, x will be equivalent to 5. 5 is not an excluded value, so 5 is my solution.